All right. So I'm trying out my new setup today to see how it works. And as you can see, I have a new webcam over there so you guys can see my beautiful face as I am teaching you math. So we're going to try it out and see how it goes. I know today we have a shortened schedule because we only have like an hour and 10 minutes of class because of the heat day. But we can still do a couple sections. At least we're going to try and see how it goes. Our first section is going to be 2.11, and it's going to be estimation in decimal multiplication. Don't forget to put your name on the top, as well as the date. It's 9/26/16, and we are doing notes for 2.11. Alright, so we've been doing a lot of estimation in our addition and our subtraction, and if you recall, those were called, what did we call those estimation? We called them front-end estimation, where we kind of looked at the beginning of the number and we used the whole number and the decimals. Let's take a look at that and remember how that worked. So we have front-end estimation, and we use that for addition and subtraction. And that's where if we had 27.179, we would use the whole number, and we would use just the tenths. And if you recall, it kind of looks, checking on my little screen to see how it goes. One thing I noticed is that I switched to another little webcam up here instead of my document cam, and it looks a little bit blurrier than before. I'm sorry about that. I'm going to see if I can get a different little camera in here and get it going. But for now, you might just have to squint to read what I'm trying to show you. And if we're going to do a quick little addition, so say we're going to use that 27.129 plus 34.642. Remember, I would line it up like normal. 27.129 plus 34.642. Again, remembering that my decimals are in line. And then I'm going to add up my tenths. So here, get rid of these guys. I have 0.7, and now I have 27 and 34, which gives me 7 and 4 is 11. 1 and 1, and then 3, 4, 5, 6. So I have 61 plus 0.7, which gives me 61.7. Easy enough. When we're doing multiplication, though, we're going to do it a little bit differently. We are going to be using what they call, let me find again what it's called to make sure that I call it the right thing. Sorry, 1 second. We're going to be looking at leading digits. Alright, so leading digits are different because we're not just going to focus on our whole numbers and our tenths. We're going to look at the first two digits of both numbers. Okay, for example, what that means is if I'm going to multiply 6.479 times 12.654, and I'm going to multiply these two. I'm only going to look at the very first two digits. So now I really have 6.4, because I've got my 1 and 2 digits here, times 12. And then this is much easier for me to multiply, because if you remember when I multiplied these two, I had a huge amount of things that I had to sum up at the end. I had like 6 numbers, and it took like 5 minutes to do one problem. This cuts it down to like 30 seconds, and we get an almost as accurate result, which is why estimation is good. So if I'm going to do this one using my leading digit estimation, I would just go as normal. 2 times 4 is 8. 2 times 6 is 12. Then I'm going to go down, cross off my 2. 1 times 4 is 4. 1 times 6 is 6. Add it up. 4 and 2 is 6. 6 and 1 is 7. Then I need to go check my decimals. I have one decimal digit, so my answer is 76.8. So the big key difference in this lesson is simply this leading digits part. So instead of this front-end estimation where we use our whole number and our tenths, now we just look at the first two digits. It's kind of a different rule than we had before. It's a little bit confusing, but that's kind of how it goes. You may be asked to compare your answer sometimes. Fortunately, not in any of the homework. So for this one, you're just going to be taking in the digits, turning them into the leading digits, and go. I'm going to go 2 more, but if you feel like you understand it at this point, then you don't have to continue going. You can get started on the homework. Let's look at example 1. If you're sticking it out with me, if you are, I appreciate you staying. Thank you. Let's take this look at this first one. We're going to use our leading digit. Use leading digits to estimate. All right, I have 5.321 times 2.301. Again, I'm going to use my leading digits, so I'm going to be like, okay, here and here, here and here. Nice. So I have 5.3 times 2.3. 3 times 3 is, and I'm going to use my algorithm. 3 times 3 is 9. 3 times 5 is 15. Look past my 3, put a 0. 2 times 3 is 6. 2 times 5 is 10. Add it up. 9. 5 and 6 is 11. 1 and 1 is 2, and 1. So I've got 1,219, but I need to check my digits. I have 1 digit here, 1 digit here, 2 digits, so I'm going to slide my decimal point over, 1, 2, for my answer of 12.19. Let's look at our second example. This time, we're going to do one more, and it's just going to be pretty much the same, but if you want to see how the process goes, I'll show you right here. We're going to multiply 9.1204 times 8.713. Again, I'm going to use my leading digits. Actually, I don't want to use these numbers because I want to show one that is a little bit different. Let's look at this one. Let's do 16.7942 times 0.0478. So looking at these leading digits, this time I have 2 out here. Oh, I'm doing 16. This time my 2 leading digits, now I don't count as 0 because it doesn't really give me any information. Instead, I'm going to look at this one and this one. So I really have 16 times 0, or sorry, the point's over here, 4, 7. So I have 16 times 0.047. And how this works and how it looks is like this. I'm going to do 7 times 6, which is 42. 7 times 1 is 7, plus 4 is 11. Then I'm going to cross out my 7. Take a look. 4 times 6 is 24. 4 times 1 is 4, 5, 6. Now I don't need to do my 0 because 0 times 6 is 0 and 0 times 1 is 0. So I can add up here and I'm good to go. 2, 1 and 4 is 5, and 6 is 1 is 7. My key here, though, is now I need to look at my decimal points. Up on my 16, I don't have any, but down here I have 1, 2, 3. I have 3 digits that are past the decimal point. So at that point, I need to count back up to 3. 1, 2, 3. So my answer is 0.752. And you can see I started with 16. It got much smaller when I multiply it by a decimal that goes way below this 0. So that's kind of key, and it's good to know. So I am accurate and I am correct. And that's going to conclude our 2 examples for this section. Go ahead and get started. If you want to rewatch any of these, go ahead and do it.